All right, so on this, let's see what we've got going on. So first thing we got to do to solve this guy is to move the 25 over. Okay, so I'm going to add 25 to both sides. Okay, and dang, that's impressive penmanship. If I'm going for award of crappiest penmanship. Okay, and then now we want to factor this thing down. Okay, now it turns out that this is a perfect square trinomial. And so we could use the perfect square trinomial factoring technique on it, but that's not like that happens every time. So I'm not going to worry about it. Instead, I am going to do the AC method. And the AC method says take your A, multiply it by your C, and we're going to look for pairs of factors that multiply to 225. So 1 and 225. You know what? I'm going to type that part out. I think that'll just be easier for everybody. Okay, 1 and 225. Let's see what else goes into this. 3 would divide into that. Let me do this cool trick on my own little calculator here. Okay, and so yeah, sorry about that. So 3 is going to go in 75 times, and 5 is going to go in 45 times. And you know, let's make this smaller because yeah. Okay, and let's see what else goes in. 9 goes in 25 times. Duh. Okay. Let's see what else we got. Anything else? That might be it. Oh no, 15 and 15. Oh, darn it. There we go. Okay, so that's all of them. And I want to know, let's see, I'm looking for a pair of numbers. Oh, whoops. Looking for a pair of numbers. Yeah, this is supposed to be a negative 30y. I did a plus. That was dumb. You probably noticed that from where you're sitting at home. And you're like, is he ever going to catch that? Haha, I did. Okay, so minus 30. All right, cool. So we're looking for a pair of numbers that multiply to positive 225 and add up to negative 30. Well, if all my numbers are positive, they're not going to add up to a negative number. So how do we multiply to a positive and add up to a negative? Well, the signs have to be both negative. So everything has to be negative. Okay, there. Now they all multiply to a positive number. Each pair multiplies to a positive and adds up to a negative. And here is the pair that adds up to negative 30. Okay, cool. So I'm going to use that to rewrite what I had, 9y squared, and then I'm going to use the circled numbers to replace the minus 30y. Okay, and hopefully you remember this from years gone by. Okay, so now I parenthesize, group up the first two, group up the last two. And so I'm going to say, what can I factor out of these two? Well, I can factor out a 3 and a y, and I'll be left with 3y minus 5. What can I factor out of the last two? Well, I can, factor out a 5, but because right in the middle of this whole 4 terms is a minus sign, I'm going to factor out a minus 5. If it was plus, I'd do a plus 5. All right, so factor out a minus 5. That leaves me with 3y minus 5. And because the two things in parentheses are a match, which they should, because the numbers we chose back here, guarantee that, I can now say, hey, out of these two guys right here, I can factor a 3y minus 5 out of both of them. and I'm left with 3y minus 5. And look at that, it's a perfect square trinomial. Both binomials are the same. All righty then, so we're almost done with this one. So it says solve for y. So now I set each factor equal to 0. I'm not going to do both of them because obviously I'm going to get the same thing. And so I'll add 5 to both sides and then divide by 3, and I get 5/3. And there was no square root of a variable in the original problem or a variable in a denominator in the original problem. So I don't need to worry about it, does my answer work or not? I mean, I should still check it, but if I did everything correctly, it'll be correct. Okay, so that's how it goes. All right, so on this one, okay, the harder way to do it is to square that out and get x squared plus 14x plus 49, and then say, hey, let's combine like terms. And 49 minus 28 is going to be 21, and then either do quadratic formula or factor it. Let's see, x plus, does that factor? Maybe it doesn't factor. Okay, so yeah, you might just have to go quadratic formula. Okay, that would be one way. Whoops, that's colorful. Okay, another way would be to say, well, let's use the fact that we have a binomial squared. So we're going to add 28 to both sides and get x plus 7 squared is 28. Now at this point, I notice, hey, I can just square root both sides. And I get x plus 7 equals plus or minus the square root of 28. And notice I'm about done. I haven't done much. Okay, so you don't have to do it this way, but it's easier. Okay, so I'm going to subtract 7 from both sides, and I'm going to say, all right, what are there any perfect squares that divide into 28? Yeah, 4 divides in. So I can do -7 plus or minus 2 root 7, and Alex is going to want you to write it out like this: -7 plus 2 root 7 and -7 minus 2 root 7. Whatever. Okay, I don't really care. Either way is fine. But that's how you do it. So yeah, move that constant term over first, then you can just square root both sides and you're home free when the opportunity presents itself like it does here. Okay, so now we get back to completing the square. And so to complete the square for this equation, step number 1, we got to move the constant term to the other side of the equation. Okay, so we've got x squared minus 12x equals minus 25, and I'm leaving a space there on purpose because to complete the square, you got to add a magic number. That magic number that you add, it's always add, is the coefficient of x, your b, as in ABC, your coefficient of x cut in half squared. That's just what works to make this all happen. So we end up with a situation like that last problem we just did. Okay, and of course I got to add up to both sides. All right, now when you do that, you always get x plus something squared when you factor this, okay? And what is the something? The something is what's in the parentheses right here. -12 over 2. Okay, now the right side is, you just tidy it up. Don't worry about getting anything else. So that'd be plus 36. And then we tidy more up. We get x minus 6 squared equals 11. All right, so for part A, we're going to pick this one that involves a minus sign. And we'll put a 6 there and an 11 there. And then it says, oh, by the way, what's your answer? Oh, okay, well, let's go get it. And you can double check this with the quadratic formula or something. All right, square root And we get, oh wait, I want to go back to red because, well, just like it. X minus 6 is plus or minus the square root of 11. Anytime you square root both sides of an equation, you get the plus or minus. Let's see, we're going to add 6 to both sides. And so you would say 6 plus root 11, comma, 6 minus root 11. And please feel free to check it on your calculator. Okay, so use the quadratic formula to solve. All right, no big deal. So I'll go, well, and notice everything's already on one side of the equation. So just jump to it. It's pretty straightforward. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and then you just, clean it up and say, all right, we got a negative 7, we got a 4, and we got a 49, and we got a plus 48, I think. Probably, yeah, looks pretty good, I guess. And then negative 7 plus or minus square root of, see, that's 97 over 4. Now, 97, it's prime. There are no perfect squares that go into 97. So you're not going to be able to pull anything out of the square root. Therefore, you're not going to be able to do any factoring. Not that 7 and 4 had anything in common anyway. So that's it. Okay. And then, of course, you could write it 7 plus root 97 over 4, comma, negative 7 minus root 97 over 4. Like butter. All right, on this one, we want to find the discriminant. Well, remember once upon a time when we did a quadratic formula and we did the part inside the square root. Okay. That's the this button here. Okay, that would be the b squared minus 4ac portion, called the discriminant. And the discriminant discriminates between what whether we have 2 real solutions or 1 real solution or 0 real solutions, or which means you have 2 complex. Because like if you end up doing square root of a negative, if b squared minus 4ac is a negative, then you're going to get 2 complex number solutions. And that's kind of the idea. So for this one, d is going to be b, it's a minus sign, b squared minus 4ac, which is 1 minus 36, which is negative 35, which is negative. So we're going to have 0 real number solutions, because if you run this with the quadratic formula, you're going to end up doing square root of a negative, which means you're not going to get real number solutions. You're going to get complex number solutions. And that's the idea. And so what if we got a discriminant that was like 17? It was positive. If it's positive, then you're going to get 2 real number solutions. And if you get a discriminant of 0, the only thing left, then that means you're going to get 1 real number solution. If you tinker with this, it doesn't take much, and it's like, oh, okay, well, that makes perfect sense.